Welcome back. Today we're going to have a look at how to find the length of an unknown side using trigonometry. So we can actually use trig to find the length of one side of a right angle triangle if we know the length of at least one of the other sides and one of the other angles. So obviously not the right angle. Remember, we have our three trig ratios. So it's important to be able to identify which ratio you're going to use for the particular triangle that you've got. So a really handy little mnemonic that you can use to remember that here is SOHCAHTOA, so SOHCAHTOA, which reminds us that for sine, we're looking at the opposite and the hypotenuse. For cos, we're looking at the adjacent side and the hypotenuse. And for tan, we're looking at the opposite side and the adjacent side. So I highly recommend, if you're ever doing trigonometry questions, write SOHCAHTOA at the top of your page just for a quick little visual reminder as to which is the appropriate ratio to use. So let's now have a look at some examples. We want to find the value of our pronumeral to 2 decimal places here. So you can see I've got an angle of 33 degrees. I've got my hypotenuse, which is 20 meters, and I want to find another side, which is P. So I need to look at the location of P according to my marked angle, which happens to be opposite. So because I'm using my opposite side and my hypotenuse, that means I'm going to use the sine ratio. So we need to write it out. Sine of our marked angle, which is 33 degrees, is equal to P, which is opposite, over 20, which of course is our hypotenuse. Now that we've got it written out quite nicely, it's simply just a point of using our algebra skills to be able to solve that. So you've got P over 20 is equal to sine 33. You want P on its own, so you need to multiply the denominator throughout. So you're going to end up with 20 times sine 33, which when we pop that in our calculator, gives us 10.89 to 2 decimal places. Now, I just want to show you another example here where our angle is marked slightly differently to what we may be used to seeing. In the diagram, you can see the angle is 23 degrees, 18 minutes. Now, that's another way of measuring angles. When we're measuring angles, we don't normally use decimal places. We use degrees, minutes, seconds. So you can use that button on your calculator to be able to enter the angle in. So looking at our diagram, we have our angle of 23 degrees, 18 minutes. We have one side which is 47 centimeters and another side which is Q. Now, we obviously want to find the length of Q. So we need to work out what ratio we're going to use. Q is opposite to our marked angle, so we're going to use that. And 47 is adjacent to our marked angle. So that means we're going to use tan because we're working with opposite and adjacent. So then we write out our information that we know. Tan theta is 23 degrees, 18 minutes is equal to Q over 47. Again, to solve that, we need to multiply throughout by 47. So we end up with Q is equal to 47 times tan, 23 degrees, 18 minutes. So to the nearest centimetre, according to the question, that gives us 20. Now that's the basics of finding an unknown side using trig, but I want to also show you, because there's another process that we need to use if our unknown ends up on the denominator of our fraction. So watch out for that video coming out soon.